Hello, my name is Jeff Seal. I'm a project engineer here at Patterson & Cook. My background is predominantly in thickener technology and thickener test work. Today I'll be presenting to you our dynamic thickener test rig, as well as the equipment, the procedures, and I'll run a typical test run for demonstration purposes. To start with, I just want to point out the acrylic test unit. This is a thickener test unit that we use for our dynamic thickener test work. We like to have it clear or transparent to see the flocculant settle, to assess the overflow clarity, and to determine how the bed's compacting and so on. Also, we have a rake mechanism. You'll see it, this is the motor for it, and the rake mechanism runs all the way down to the base here, and that's a rotating picket. We have a feed well in here as well too to help distribute the solids and have contact and mixing between the flocculant and solids. From that feed well extraction point, there's a deflector cone which allows the solids to settle evenly over the thickener area. We have a feed tank mixing up. Typically it's around 200 liters in volume. During the mixing we have 2 to 3, perhaps 4 baffles in the mixing tank to ensure proper mixing of solids and liquid. And we have a feed line coming off, inserted and coming off the bottom of the feed tank. From there we have it being drawn off through this peristaltic feed pump. It's very important to ensure that the solids concentration is at what you're targeting and that this pump is calibrated to what you're expecting the flow rate to be. This goes on to calculate your solids loading rate. From this point on, we go on to the flocculant dosing. Here at Patterson & Cook, we do an inline flocculant dosing point for flocculant of the material, and we ensure that it's after the feed pump. This ensures that the flocculant doesn't get sheared during the pumping. So we have 2 flocculant injection points. You can introduce coagulant to begin with, then flocculant, or you can have 2 flocculant injection points, which we typically do, but it gives you a lot of flexibility in terms of that. From there, we go on to the feed injection point, and it basically gets injected into the feed well here. The clear fluid coming off the thickener is being discharged into this discharge tank at the bottom here. We run a test up to about 200 millimeters in height, and at that point we shut off both these pumps, wait a minute during static raking, and then we turn on the underflow pump at a relatively slow rate to ensure that the material is being extracted uniformly and not just preferentially through the center of the material. Also, during a test run, we will be taking overflow clarity wedge samples to ensure that the overflow clarity is improving, or if it's becoming worse, that we're aware of that. So I'm going to begin the test. I'm going to turn on the flocculant. This has already been calibrated and with the actual flocculant that we have in here. Now I'm going to be turning on the feed pump, and it's going to be drawing material off the feed tank, and it's going to be entering into the feed well. You'll see how the material flocculates very well and how it hits the deflector cone and gets dissipated over the area of the thickener and then begins to settle. I also have the rake turned on at about 3 RPM. That's important to dewater the material. The rake blades are angled at a certain angle so that it pushes material towards the center, and it's extracted at the central extraction point at the bottom of the thickener. We're nearing the 150 millimeter bed height at this point. The pump's been running for the last 10 minutes, let's say. The overflow's gotten a bit cloudy. We can run a few tests and determine what the flocculant dosage is and so on. I also like to grab an overflow sample with our clarity wedge. There's a scale on the back here with 0 to 46. If it's a cloudy overflow, you'll only be able to see up to 1 or 2. If it's very clear, you'll be able to see up to 46. We're nearing the 200 millimeter point, so I'm just going to grab an overflow sample really quickly. You have to grab this overflow sample before you turn off the feed pumps and the flocculant pumps. And this is the sample I'll be drying, determining the overflow percent solids, or the total suspended solids in the overflow. I'll be placing that in the oven at the end of the test. At this point, I'm going to go ahead and turn off the pumps and turning off the agitator. I'll let it rake statically for about 1 minute. I'm going to turn on the underflow pump at a very slow rate. I've also placed an underflow bucket here to collect the waste material. Once I see a consistent material coming out, I'll grab the the underflow sample. And then this is just a tray sample that we can dry for underflow solids. I'll turn it off. And I've obtained my 2 samples that I'll be using for analysis at the end of the test work. During a typical test matrix, we run about 7 to 8 different tests. Our first 4 tests consist of maintaining a consistent solid loading rate or feed rate and adjusting the flocculant dosage. So we'll run one test, let's say at 50 grams per ton, and then we'll run a second test at a lower or higher dosage. Basically a matrix of 4 tests to determine the optimum flocculant dosage. Once we determine that optimum flocculant dosage where the underflow density is the highest, we'll maintain that dosage, but we'll adjust the feed rate. And by adjusting the feed rate, we're adjusting the solid loading rate. So that's our typical test matrix of dynamic thickener test runs. So we'll be able to obtain 4 tests from the flocculant dosage and 4 tests from the solid loading rate parameters.